So far, we have seen how we can easily create tests for our models based on our initial requirements, how to manage, validate, and document them. But how do we know if we have fully tested our design with this test? Well, model coverage helps us validate our model test by measuring how completed the model objects are tested. For model objects, I mean our Simulink blocks and the states and transition of Stateflow charts. Model coverage calculates how much the test cases exercise simulation pathways to a model. It is a measure of how fully the test cases test a model using a percentage of pathways that the test cases are able to exercise. And there are many industry standard metrics such as decision, condition, modified condition decision coverage, or MCDC that we can use. Let's see how we can achieve, see, and analyze these metrics easily in Simulink. Before starting the test that we have created for BMS state machine, we have the possibility to enable in the test manager some options that during the test run can collect the coverage metrics that I said before. On the test file, in the coverage settings section, we can enable the metrics we want before running the test. You can see that I had already enabled decision, condition, and CDC before starting the test. This means that I can already see the results. If we go back to the Results tab, selecting each individual test, I can see the metrics calculated on that individual test. More important, of course, is to see the metrics on the whole test group. And we can do this simply by selecting the container of all the tests. In this case, we have reached 73% MCDC. How to analyze on the model what was covered and what was not? By clicking on this button, the coverage will be highlighted on the model with the colors red and green. Green means total coverage. Red means not total coverage. We therefore need to do a more in-depth analysis. For example, we may have gone through this transition, but talking about MCDC, we may have tested only some of the combinations of conditions of these AND operations. If you want more details here, you can open the coverage view, which will open a new window on the right. Here, through hyperlinks, we could browse coverage and model and see the details. In this case, we discover that the condition of for present has never been tested. So we'll have to add a new test for this. Speaking of reporting, useful for certifications, obviously it is done automatically by clicking on this arrow, and a HTML file will be generated, enclosing the details of what has been updated. We know from many customers that as you define test and measure coverage, it is a difficult challenge to reach 100% of coverage, and it is frequently the last few percent that take most of the efforts. This brings us to a new topic, the automatic generation of new tests. The initial situation is this: the creation of test cases to obtain a coverage, which most of the times is partial. The test generator in Simulink Design Verifier can help us in the workflow by taking incomplete coverage as input so that new tests are specifically targeted to missing coverage, and when combined with the initial test give you a suite that can achieve the complete coverage. Let's see how to activate this feature. If you remember, we had a partial NCDC coverage of 73%. Simply using this button, we can invoke the test generator and enter some information to say how and where to create our new test. The test generator, starting from the starting coverage, will calculate some goals and try to reach the total coverage to a new test for the model's uncovered path. A new test harness with the new test will be automatically created and added to the test manager. The new test can be seen from here. The generator has the test generator has added 13 new iterations. To this arrow, we can open the test harness that contains them. Having chosen the creation of a signal builder, we can find and analyze the new 13 tests inside it. Back to the test manager, we can run this new test and see the results in terms of model coverage. The new test covers 47% MCDC model coverage. The interesting part is to merge the coverage of the old test and the new ones, which we can calculate in this way. And we can see that coverage has risen from 73% to 87%. And then again, we can analyze the transition still in red. One question that might come naturally is, why didn't we get 100% of the coverage? Well, in general, there are several reasons that would lead us to a non-full coverage on the model. The first one that comes to mind is missing testing. The second, missing requirements. In the previous case, since we invoked the automatic test generator, the most likely cause are design errors, for example, dead logic. Having a dead logic in our design, even the code generator will surely fail to achieve 100% coverage. Design Verifier gives us the ability to detect hidden runtime errors statically without to do any simulation. We support detection of design errors such as integer overflow, division by zero, array out of bounds, range violation, and dead logic. These scenarios usually indicate bugs in your designs. When we run these, safe contracts are highlighted in green and construct violations in red. If you want more details, please refer to the short video on YouTube, How to Automatically Detect Design Errors in Your Simulink Models.